Namaskar, dear learners. I am Dr. Shweta Tripathi from School of Engineering and Technology, IGNOU, New Delhi. And today we are going to discuss about fuels and combustion. This is from the course MRW 001 Energy Conversion of MSc Renewable Energy and Environment Program. So, as of now, we have learnt about energy conversion process. What are energy conversion processes and why do we need energy conversion? So, in that line, today we are going to discuss about fuels and combustion. So, basically, it is a energy conversion process where the chemical energy of any substance or fuel is converted into heat energy, generally in the case of combustion. So, today we are going to learn about fuels and combustion. So, you all know about combustion and you all have seen combustion in your day to day life. So, basically, when we talk about combustion, it is a chemical reaction or chemical process, we can say, in which a substance generally reacts with the oxygen. Because air is available, so the oxygen that is there in the air is utilized for the combustion of fuel. So, generally, we cannot call any chemical reaction of a substance with the oxygen as combustion. For example, rusting of iron. It is also an oxidation process where a substance is having chemical reaction with the oxygen. So, what is the difference between the combustion phenomena and the rusting of iron? The combustion, both are chemical reactions, but here in case of combustion, some heat energy will be released. So, here we can see that in the case of combustion, the reaction will be with oxygen and we will get heat. So, any chemical process in which a substance reacts with oxygen to give off heat is known as combustion. And generally, the substances which undergo these reactions or the substance which react with oxygen and give us heat energy are known as combustible substances or fuel. So, there are some important characteristics of the fuels. After knowing those characteristics, you can decide whether the fuel is better or not. This we will be discussing. And depending upon the properties of these substances, the oxidation process of that particular substance also is different. For every substance, the chemical reaction will be different. So, generally, the combustible substance is known as fuel and the process is known as combustion and we get heat energy. So, if we talk about the things which are important for the combustion, one is the substance or combustible material or fuel, another is oxygen. So, because oxygen is helping here for the combustion phenomena, so we call this as a supporter of combustion. Air or the oxygen that is present in the air is known as supporter of the combustion and the chemical reaction that takes place is known as combustion where the immense amount of heat is released. So, sometimes this heat energy is with light energy also, which is known as flame. Whenever you have seen that LPG is combusting in your oven or the gas chulhas at your home, a flame is there. So, that flame is a light energy and the heat that is absorbed by the utensils or whatever you are going to cook is because of the heat energy. So, basically in the combustion process, two kinds of energy are there. One is heat energy and another is light energy. Generally, we call this light energy as a flame. Why flame? Because it is visible also and it has certain amount of heat also. So, we call that as a flame. So, first we will discuss about the chemical equations that are there for the combustion and then we will discuss about the types of combustion. So, generally if we talk about the fuel, a very important component that is there is carbon. So, everywhere whenever we talk about the fuel, the carbon and hydrogens are there. So, mostly the fuels that we know are having the composition of hydrocarbons. And this hydrocarbon reacts with the oxygen and we get carbon dioxide and some water vapor and obviously the heat energy. So if we talk about the burning of a charcoal, so charcoal is basically a form of carbon. So here carbon plus oxygen will give carbon dioxide and heat. Here in charcoal, we are assuming that charcoal is a form of carbon. So here we don't have any hydrogen component, so we are not getting water vapor. But if we talk about the methane or the natural gas that we are burning nowadays, that is methane. So when we talk about the burning of methane or combustion of methane in the presence of air, then we will get carbon dioxide and oxygen both. And obviously heat is there because these substances are combustible and they release heat energy. Let us learn about the conditions which are required for the combustion. So one is the presence of combustible substance. Another is the presence of supporter of the combustion, that is air. And the third thing is they should mix up and some ignition should be there. So we need a igniter or the substance which may help us to get ignition. So what is ignition now? Ignition is whenever a combustible substance is ignited or it gives a spark or it releases energy or the combustion of that particular combustible substance starts. So igniter could be any substance, like we can take matchstick etc. for igniting. And another thing is sometimes the fuels have auto ignition also. Why auto ignition is there? It is because every substance has its ignition temperature, which is the minimum temperature at which the ignition will start. So if the atmospheric air is at that particular temperature where ignition can start of that particular substance, then we don't need any igniter. The auto ignition will take place there. And if the surrounding air has the temperature lower than that ignition temperature, then we have to spark or we have to make that substance reach up to that temperature so that the combustion may start. So the third thing that we need is the igniter or attainment of ignition or some kind of kindling we have to give. Then comes the substances like magnesium. For example, magnesium has a white colored flame, if you have ever seen it. So whenever we have to burn magnesium, the auto ignition temperature of magnesium is about 35 degrees centigrade. So if the surrounding air's temperature is 35 degrees centigrade, then it will auto ignite, or otherwise we have to maintain the temperature of the surrounding at about 35 degrees centigrade, either by heating or by maintaining that particular temperature by giving a spark or ignition etc. We can do it by any means, but we have to maintain that at 35 degrees centigrade. Then only it will be auto ignited or ignited and the combustion will take place. Now air or oxygen which helps in burning is known as the supporter of combustion. You might have seen that whenever we burn the candle, if there is lot of air, the candle is not able to burn. So what is the reason behind that? We are telling that air is supporter, but when the flow of air is more, the candle is not burned there. So there is a adequate amount of air is required for the combustion of anything. So for different fuels, that adequate amount of air will be different depending upon their chemical formula, the chemical reaction that takes place in between them. So every hydrocarbon need different amount of air, and we call this quantity of air or the ratio of air that is required as stoichiometric ratio of the fuel. So stoichiometric fuel air ratio is the ratio adequate amount of air which is required for the complete combustion of that particular fuel. We can see that if we close that particular glass jar, movement of air or the passage of air is restricted there, then also the candle will not burn. So it shows that we need air and adequate amount of air is required for particular combustion. Now comes the ignition temperature. Ignition temperature is a minimum temperature which is required for a combustible substance to heat before it catches fire. So, we can say that a combustible substance cannot catch fire until and unless its temperature is not reached up to that particular temperature. If the surrounding temperature is lower than that ignition temperature, it will not. And this is very important. Why? Because we have to store these fuels also. So, how can we store the fuel? Always the storage of the fuel should maintained at the temperature which is lower than their ignition temperature. So, before storing any fuel, we should know that what is the ignition temperature of that particular fuel. Now, do you know why if a person is caught in fire, it is covered with a blanket? It is because if the clothes of a person is burnt and now we have to stop the fire, then what we have to do? We have to wrap it with the help of a thick blanket. Why? Because it will cut off the supply of air, that is the supporter of the combustion, that was oxygen. It should be cut off, so the fire will be put off. And another thing is we pour out water for overburning. So what happens when we pour out water? The excess amount of heat energy is absorbed by the water and then also the fire goes off. So these are two methods which are generally used for the prevention of fire. So, because they control the combustion reactions. The reaction that goes on and on is stopped immediately after this. Now comes the types of combustion. So these are the types of combustion: slow, rapid, spontaneous and explosive. First is slow combustion. In a slow combustion, generally the combustible materials burns at a very moderate rate and produces heat and light energy. Generally, this is occur when the supply of air is insufficient or inadequate. Then comes the rapid combustion. In rapid combustion, the gas burns rapidly and again it produces heat and light. Here also flame should be there, and this is known as the rapid combustion because the speed of combustion is more. So for this we have many of our domestic examples like the gas burners that we are using in our kitchens and IC engines, etc., where petrol is burning, LPG is burning, diesel is burning. They are all example of rapid combustion where the combustion takes place continuously and rapidly. Then comes the spontaneous combustion. In this combustion, actually external heat is not given. This combustion is because automatically when any substance reaches to its auto ignition temperature, then spontaneous combustion takes place. In no time it takes place. So it is a natural combustion basically, and this is because the atmospheric temperature is equal to the ignition temperature of any substance. Then comes the explosion. So generally this explosion is uncontrollable combustion. So here large amount of gases are involved and tremendous amount of heat and light is there. And sometimes they produces sounds also because the amount of energy is so much, it is explosive in nature. So generally the sound is also there. So the firecrackers are the example of this kind of oxidation reactions. Then comes the differences between the rapid combustion, spontaneous combustion and the explosion. So if we talk about the spontaneous combustion and rapid combustion, spontaneous combustion is only spark will come. It will be because the auto ignition temperature of that particular combustible substance is near the surrounding. For example, burning of phosphorus, magnesium, etc., because their ignition temperature is so low. It is nearly equal to our room temperature, generally 35 degrees centigrade, 40 degrees centigrade. So anytime if the temperature of our environment is like that, so spontaneous combustion will take place. So we keep these substances with some mixture or alloys only. Okay. Then comes the rapid combustion. Rapid combustion is the combustion which takes place at a faster pace in a rapid pace, and we have to maintain it with the combustible mixture. We need combustor and we need an igniter, and the combustion process or the reaction will go. So here chain reaction will be there, and the reaction will end only after the completion, or if the substance is no more left, then only the combustion process will stop. And this rapid combustion is when uncontrollable and it produces sound also, then it becomes the explosion. Now what is fuel? So we have discussed that any combustible material is known as fuel, which produces energy when it is burned. So any substance which is generally available and it burns in air at a moderate rate and it produces a large amount of heat energy is known as fuel. So basically there are many characteristics of fuel, but the most important characteristic is the calorific value of fuel. And what is calorific value? Calorific value of any fuel is the energy that it contains. So if we burn 1 kg of fuel and it gives us 1000 kilojoule of energy, so the calorific value of that particular fuel will be 1000 kilojoule per kg. So the calorific value is the heat content of any fuel. So generally here the chemical energy of fuel is converted into the heat energy, and whatever we are getting is output, and depending upon this we calculate the fuel efficiency also, that we will be discussing next. So here generally when we talk about the fuel, what we assume for the ideal fuel is that there should be no residue left. So if the residue that is left after the combustion of fuel is less, that fuel is best. But no such fuel is available. Okay, we have to somewhere compromise between what we want. So some of the fuel characteristics are available and some are not available. So each and every characteristic is not available in each and every fuel. So depending upon the process or the equipments where we are going to use them, depending upon those we choose or we select the fuel which will be better for that particular operation or that particular conversion or that particular equipment. So if we talk about the properties of fuel, generally the excellent properties of fuels are octane number, cetane number, ignition temperature, calorific value, pour point, cloud points, etc. Apart from these, the general characteristics, what are the characteristics that we have to keep in our mind are the readiness or the availability of that particular fuel, then how much energy content is there or the calorific value of that particular fuel, then storage of that particular fuel. As we have discussed that ignition temperature should not be equivalent to the room temperature. Why? Because the storage of that particular fuel will be difficult. Then transportation of that particular fuel, which will depend upon the energy density. According to the weight of any fuel, how much energy content is available there. So we have to see that the energy density should also be better. Then it should burn at slow pace, okay, because if it will be burning in higher pace, we need more amount of fuel. So in order to get more energy from less amount of fuel, the best characteristic of any fuel is that the burn rate should be slow and the combustion should be controllable so that the explosion could not take place. Then it should have high calorific value, it should be cheap also. Apart from this, their octane number, if we are using it in petrol engines, then cetane number for the diesel fuels. Similarly, cloud point or pour point. Pour point is the point where the fuel will flow. So the flow of the fuel is also important. Apart from these characteristics, these fuels are available in solid forms, liquid forms and gaseous forms. So we have to choose these things also, that whether it is in solid form or liquid form, which kind of fuel we are going to use. If we are going to use the fuels in the boiler, suppose, then we can go for solid or liquid, any kind of fuel. But if we are going to utilize the fuels in our combustion engines, internal combustion engines, then we have to go for the liquid or gaseous fuels. So there are various properties of solid liquid and gaseous fuels. For example, liquid and gaseous fuels have better combustion than solid fuels. There are no residues in liquid and gaseous fuels, but solid fuels have residues as well. So depending upon these characteristics we have to choose, but solid fuels are cheaper than liquid and gaseous fuels. So solid fuels are the fuels which occur in the solid state at room temperature. Liquid fuels generally occur in liquid state at room temperature, and generally they are derived from the petroleum, but we have biofuels, ethanol, etc. also that are available as liquid fuels. And when we talk about the liquid fuels and gaseous fuels, the combustion of gaseous fuels is better than liquid fuels. So here when we burn liquid, we have some unburnt hydrocarbon left over there. Carbon dioxide is also there, and carbon monoxide is also there, because when the combustion is not complete, the carbon monoxide emission is also there. Though nitrogen is an inert gas, but when it reacts at high temperature with the oxygen, we get nitrous oxide, etc. also, which are again the greenhouse gases. So in case of liquid fuels, we get improper combustion or incomplete combustion sometimes in comparison of gaseous fuels. The third classification is the gaseous fuel. Here the fuel occur in gaseous state at room temperature, and water gas, producer gas, coal gas are its example. CNG is also its example, and these are the cleaner fuel. The emission is less, though we get carbon dioxide emission there, because whenever there will be complete combustion for any hydrocarbon, we will get carbon dioxide. So this is all about the fuels and combustions that we have learnt. Thank you learners. Namaskar.